Look at speed and velocity. You may have heard of speed as how fast an object is moving. Then what is velocity? In physics, speed is defined as the ratio of distance to the ratio of distance traveled to time that it takes. Or you can say speed is distance traveled divided by time it takes, and it's a scalar quantity. The units for speed are as distance as measured in meters, and time is measured in seconds. So the units for speed is meters per second, or ms-1. So let's look at velocity. Velocity in physics is defined as the ratio of displacement to the time it takes to complete that displacement. We use the letter V to represent velocity, and if we put it in equation, we write it as V equals displacement over time it takes. When we put these in a symbol form, displacement is represented by S and T is representing the time. And the units for velocity is derived from this equation. So displacement is measured in meters and the time is measured in seconds. So again, the unit for this velocity is meters per second, or ms-1, which is same as speed. But velocity is a vector quantity. What it means is that it must have direction, and it gets its direction from the vector quantity in the equation displacement. So it's same direction as the displacement. Let's do some examples. So let's say an object moved from, let's label that start point, to the end point, towards the end point, traveled 100 meters to the west, and it took 200 seconds to travel. So if we want to find the speed, we're going to take 100 meters divided by 200 seconds, which is equal to 0.5 meters per second, or you can write it as 0.5 ms-1. Whereas the velocity is 100 meters west, the displacement has the direction, and again we're getting the same magnitude, but we have to additionally provide the direction. And the direction of the velocity is same as the displacement. So let's take a look at another example. Let's start from the start point, moving towards the end. And this time I'll draw the directions again. So if you notice, the object is moving towards east. Let's say it's traveled 100 meters towards east. It took about 50 seconds to travel. Now let's do the calculations. Speed is 100 divided by 50, and the answer is 2 meters per second, or you can say 2 meters ms-1. Now when we calculate the velocity, we have to give the direction for the displacement, 100 meters east divided by 50 seconds. And then when you calculated, it's the same magnitude, 2 meters per second. But then again, don't forget to give the direction for the velocity, which is a vector quantity. Let's take another example. Let's say we start from the start point towards the end, travel 5 meters, 8 meters, and then 5 meters again. I've represented the blue arrow to represent the displacement. Orange arrows are representing the distance traveled. So for calculating the speed, I need to take the distance traveled, which is 5 plus 8 plus 5, and divided by the time for the total trip. That will give me the speed that it took. To find the velocity, I need to take the displacement divided by the time it takes. The displacement is 8 meters and divided by the time 3. The answer is 2.67 meters per second, or ms-1. If I look at the compass direction, and notice that the object is moving towards east, so that's my final answer. Notice the velocity and speed are different. So far we have considered the situations when object did not speed up or slow down, and in that case we call it an object moving with a constant speed or velocity, and we refer to this term as uniform motion in physics. Or you can say the object is moving uniformly or has uniform motion.